So this recording's been an absolute nightmare. So it doesn't, there's a bit of a jump cut or something from what went previously, then we can relax about that and you'll understand why, because I've ended up whole kinds of technical issues with my recording, which has been very frustrating. But there's the equation that governs the evolution of the density on the characteristics. So the only thing we've got to do here is we've got to remember what the formula for C is, and C is B naught over rho max minus 2 rho. And we're going to assume in almost all the calculations that we non-dimensionalize, so those are equal to 1. Okay, like nice and simple. So C is going to be 1 minus 2 rho. Now, everything will become apparent about this formula and how it all works when I do a computation on MATLAB. Let's go to MATLAB. MATLAB starting up. Okay, I had it all worked out before in the one that didn't work video. Come on, MATLAB. Okay, so spare me from the 78th time I've done this, but I do, one advantage is I do have the commands here. So there's the density and there's X. I've set up. Okay, so that's the initial density. Oops, what have I done here? I'll do that again. There's the initial density. So, it's a nice Gaussian. So what's going to happen is this traffic here is stuck, because at rho max there's no movement of the car. Okay, I've got a storm running past, heavy wind. I've got to keep going on because I'll be going absolutely mental if I don't finish this. Alright, so just watch the commands and try and hear the voice. Okay, so we're going to try, this is the density is 1, it's going to go backwards because the characteristics are moving backwards. Here the characteristics are going forwards with slope 1. So you're going to get some kind of problem here, but let's have a look how this works. So we go, we're going to plot the solution sometime later. So we keep the same rho naught because we know the values get carried along these characteristics, and we move the x. That's what that curve actually, that equation actually means. I mean, change the x but keep the y the same. Unrecognized variable C, I forgot to define that. It's 1 minus 2 times rho naught. Okay, and my mistake. And there it is. So that's what happened time t later. It's tipped over like that. And you notice here that it's not immediately, the characteristics are going in different directions. One's coming here at positive slope 1, one's coming here at slope minus 1. They're going to meet at some point, but they don't meet immediately. So there's no problem, and you can see what happens here. Everything's fine, that's a perfectly well-defined function. But if I increase the t, say to 1, and it tips right over like that. I'm going to take the hold off. Okay. And we'll just have a look at that. Just one picture at a time. So there's t is 0. And then it starts to tip, 0.4. It's almost become vertical. And around about 0.5 it becomes vertical. And then it's crossed. And we go, say, to 1.5. We end up with it tipping right over like that. And of course this is not going to work because it's not a function anymore, is it? There's 2 values here. So something has to happen, and those characteristics crossing is called a shock. So you're going to draw some pictures in MATLAB like this and calculate when the shock test forms and all kinds of stuff. But you've seen the idea here why the solution, you can carry the solution forward, but you can't go to a point in space and work out a formula for what the solution is going back. And you immediately have this problem of the characteristics crossing each other.